All right. Good afternoon, folks. For those who have been with us throughout the day, thank you. Now we have Kyle, who is the global cloud solution architect. He's going to talk about one of the cool topics that are there on ML model operations, and I will let Kyle take over. Kyle, over to you.
Sure, thank you so much. So a little bit about myself. I'm Kyle. I'm a global cloud solution architect at Microsoft. So I work with top customers in APAC for their data projects to get it up and running on Azure, especially in the area of AI, data sciences, data warehousing, and business intelligence. So aside from this, I also do like other certifications like Microsoft, IBM, Tableau, and INSEAD. I do coaching for other stuff as well. So other workloads that related to the data and AI. So I'm happy to share that with all of you today. If you guys hop on LinkedIn, you can feel free to connect with me. GitHub as well and Medium. I'm all around. All right. So agenda for today. So in this talk, I would like to cover pretty much like end-to-end process of the machine learning process. I'm gonna focus a lot on the deployment area. What is MLOps and why? And how does the sample architecture look like for the machine learning operationalizations? And lastly, I'm gonna be using the two technologies all together, which is the GitHub Actions and Azure Machine Learning, how that works together and get it up running on Azure. So let's first run through a simple representation of how the machine learning project lifecycle be, right? So typically you have in this kind of process, you define the business goal. Typically you have the business problem that you want to solve. Um, Then you gather the data. What's the data required for this machining project? What kind of data sources that we need to gather and glean for this project? And then data scientists or any machine learning practitioners start building machine models, right? Now, when it comes to machine learning model building, that's iterative process. Of course, you get to try out different models at a time. Could be from the simplest model to the most complex model that you can think of, from deep learning to any framework that you think about. And then the toughest part is typically the deployment of deploying these machine learning models, right? So you try to deploying it to the right environment, and in a way you want to automate this process too. So all of this goes iteratively. You're not just finishing this model and then done, right, and get off this project, but you need to maintain it. You need to automate this workflow, and that's why MLOps is coming into the picture. By the way, I guess this picture from Introducing MLOps, which is a really good book. I highly recommend it. This is available on O'Reilly, so you can find it available online. Really highly recommend it for any MLOps practitioners. Yep. So let's diving into it a bit more, right? Into this roles and responsibilities of like who's going to be involved into different processes. Like I said, like you started with a business question, so you need subject matter expert and line of business, right? LOB. So once you identify the right line of business and the right business questions, then you start gather the data and develop the models. And typically, that's the role for data engineers and data scientists work together for laying out the foundation of ETL and data preparation, including the model training and experimentation. If you have the subject matter expert, that would be a really good thing as well. So you can add the opinions or add the things into the model, add the features and ideas to the model. especially in the feature engineering part where you want to enhance your model. So that's the process when you work together with all across the teams. And not just data scientists, you may have another role, which is the AI engineers who are going to be deploying the model, right? So in this process, you have ML architects, data engineers, software engineers work together to lay out this kind of process for production, ship it from development to production with a continuous integration and continuous delivery pipelines. You need to do like that kind of auto scaling as well, and containerization, testing, etc. And lastly, usually the last step will be the monitoring and feedback loop. You see that in action later on as well. With this kind of locking and alerting, performance drift, model evaluation, and it goes back iteratively to retrain the model. And this process can be fully automated actually if you have the right MLOps environment in place and set it right iteratively. So all in all, this is all about a robust automation and trust among teams, right? So if you can enable this kind of automation across the teams, it gives you much more like productivity and much better communication and collaboration among teams. So seeing it in furthermore, like in this model development phase, where of course there's going to be very iterative, where you got some training data from different data sources. You already process your data. It's of course going to go through the data exploration phase. You do some feature engineering and model comparison, trying out different models from random forest to deep learning models, compare the performances depending on the machining problems you're looking at, and you get the best model out of it, right? So you could probably like training like 30 models, only choose one, prepare it for production, deploy to production, and monitor it, and it goes iteratively. So this will give you a good view how that looks like for MLOps. So if I were to recap why MLOps were to be a really nice thing for any machining project, is that it really enables you like for model reproducibility, model validation, model deployment, and model retraining. You get to check all these boxes in an automated way, and it bridges the gaps between data scientists and software engineer, right? So data scientists not just build a code and then done, but you get to work with the software engineers and put it into the DevOps process, right? So I'll just talk a bit on how data scientists work as well. So typically in this kind of MLOps environment, you can have, let's say you have a team of 5 data scientists. You can have them working in 5 different branches for the project, right? And you can merge them to the master branch and whatsoever. That kind of run to basically doing the model validation kind of thing, model training, run the training code, get this output file, run in the store history. So you get to check all these boxes where you can track the changes in your code and update it like iteratively and instantly. Right? So this is the beauty of how the platform looks like when you get to do it end to end. I'll lay down some sample how the sample architecture for MLOps looks like. Okay, so this may be confusing to some of you, but be patient with me. The different components here, the technology being included in this component. So first of all, you definitely need the Azure machine learning for basically like keeping the lifecycle project running for data science team or machine learning team in the organization. So here you can create your workspace, like think of it like your ML sandbox or ML environment, doing the unit testing and get the compute up and running, could be the CPU or GPU. You'll see it more later on in later slide as well. And you can keep track of your model versioning and data versioning too in this platform. So that